Hello. In this episode, we are going to show how to prove that a number is irrational. So the first question is that prove that the square root of 2 is irrational. Then given that the square root of 7 is irrational, we want to show that 2 plus root 7 is also an irrational number. Now, first of all, I want you to remember that a number is rational if it can be written in the form of A over B, where A and B do not have a common factor and B is not equal to 0. For example, if I give you 5 over 10, you can simplify it by dividing throughout by 5, which is 1 over 2. And 1 over 2 is in its simplest form. You cannot find, there is no common factor between 1 and 2 except 1 itself. So that is a rational number. Now, an irrational number is any number that cannot, I emphasize, cannot be expressed in the form A over B. For example, the number pi is 3.14159 and so forth. It is just going. The square root of 2, if you put it on a calculator, it will give you 1.414213 and so forth. Now, in this case, we are interested to show or to prove that the square root of 2 is indeed a rational. So we are going to use an approach that we call contradiction in mathematics. Now, contradiction is a method where we assume that something is true, and then in the process, we realize that it is not agreeing with a certain fact. Okay, the first thing, we assume that the square root of 2 is rational. So what does this mean? This means that the square root of 2 can be written in the form of A over B, where B is not equal to 0 and A and B do not have a common factor. Now, let us square both sides. So if we square both sides, we are going to have A is equal to A squared over B squared. Let us multiply throughout by B squared. So this is 2B squared is equal to A squared. Now you realize that A squared has been written as 2B squared. What does this mean? You know that a number is even, say m is even if you can find a number k such that m is equal to 2k. So you can see that a squared is equal to 2b squared. So we are saying a squared is even. Now, a squared is even. For example, you have 4 is an even number, and if you find the square root of 4, which is 2, is also an even number. So therefore, we conclude that a can also be written in the form of 2k, where k is an integer. So since a squared is even, we know that a is also even. So a can be expressed in the form of 2k. Now, from here, we can square throughout here. So this is a squared is equal to 4k squared. Okay, so what does this mean? So this implies that from here, we can say 2b squared is equal to, where there is a squared, we put 4k squared. All right, now let us divide throughout by 2. So this implies b squared is equal to 2k squared. So you can see that also b squared has been written in the form of 2 multiplied by something. So this implies that b squared is even. So therefore, we also conclude that b is also even. So b can also be written in the form of, say, 2 multiplied by r, where r is also an integer. Let us put the pieces together. Remember, we said the square root of 2 is equal to a over b, where b is not equal to 0. So at this point, we have reached a point where we're saying the square root of 2 is equal to, so we said it is equal to a over b. Now, what is A? We said A can be written in the form of 2k. So this is 2k is equal over B. We said B can be written in the form of 2r. So we can cancel out 2 and 2, which is equal to k over r. So if we continue with the same process from the first, if we continue with the same process, starting with k over r, we can also find another numbers m over n. Okay, so this process continues without ending, which is contradicting our definition of a rational number. So this is contradiction. Therefore, the square root of 2 is irrational. The second one, we have been given that the square root of 7 is irrational. Now, we want to show that 2 plus the square root of 7 is also irrational. This is very simple. We are going to use contradiction again. So we assume that 2 plus the square root of 7 is rational. So what does this mean? This means 2 plus root 7 can be written in the form of a over b, where a and b have no common factor and b is not equal to 0. All right. Now let us rewrite this. So we can write root 7 a over b minus 2. So this can be simplified as a minus 2b over b. So we know that the sum of integers is also an integer. So a minus 2b can be written as r, where this thing is just an integer, right? So a minus 2b is equal to r, where r is just an integer. So what does this implies? This implies that the square root of 7 can be written as r over b. But this is a contradiction, okay, because we have been given that the square root of 7 is irrational, and we know that an irrational number cannot be written as a fraction like this. So therefore, 2 plus the square root of 7 is also irrational. We end here. Here is something for you to try out. Remember to put it in the comment section with the detailed working.